Hello together, my name is Ralf Stemme and I'm the product manager for the GESTRA severe service control valve. Here today I would like to present to you the ZK313. This is a high pressure control valve which we are using in steam water cycles and power stations. But before I show to you the special valve features and the design details, I would like to go to the scheme of the power station to explain which are the typical applications for this valve and where we have got the real customer benefits. Okay, at first let's have a look together at the simplified scheme of a steam water cycle of a power station. Power station has got the task to generate electric power with a generator at the turbine. So to get the steam for the turbine, we have got here the boiler consisting out of an evaporator, the superheaters and reheaters. The boiler will be fed finally by the boiler feed pump, which gets the water from the feed water tank. So at the end, the boiler will evaporate the water, produce steam, turn the turbine, the steam will be condensed after the turbine in the condenser and will be pumped back by the condensate pump to the boiler house into the feed water tank. Typical applications for our severe service control valves are the blue colored items here. These are valves for steam, water and for flashing water service. An example for water applications are, for instance, the feed water control valve or the spray water control valves at the steam coolers between the superheaters or reheaters or at the bypass stations. An application for severe service at flashing water are, for instance, the start-up blow-down valves of the boiler drum, then all drain and warm-up valves for the boiler, for the piping system or for the turbine plant. And then we have got even high pressure steam control valves which have to handle high differential pressures. These are, for instance, the boiler vent valves at the high pressure steam lines. The application which face the highest differential pressure, however, in a boiler is a feed pump recirculation valve, where often power stations have got problems with cavitation damages. As an example, I would like to pick up only a few applications. Let us start with the feed pump and then the feed water recirculation valve for the boiler feed pump. This valve has the task to secure a minimum flow through the boiler feed pump if the feed water control valve will close or interrupt the flow into the boiler. And this valve here has to face enormous high differential pressures, sometimes up to 500 bar or 8,000 psi. And here it is mandatory to have a real wear-resistant and reliable valve design with a perfect tight shutoff. Same even is necessary for all the drain valves. Here's an example, these are the boiler drain valves. If we have got a leakage of a drain valve, then we are wasting high value steam to the atmosphere through the start-up flash vessel, and we cannot use the steam in the turbine. Therefore, it's important to have a zero leakage even directly from the beginning of the service of every valve. Another application where a perfect tight shutoff with zero leakage is very important are the spray water control valves. If these valves are leaking, then thermoshock crack damages may appear at the steam coolers or at the bypass stations for the turbine. If we look at the warm-up valves and at the vent valves, here for instance at the high pressure steam lines, here we are facing high differential pressures as well, and these valves should be closed if the power plant is in the usual operation conditions. And if we are watching steam clouds on the top of the roof of the boiler house, then we know that we are losing here energy and finally money. Now the question is how we can realize a whir-resistant valve for very high differential pressures where we are facing flashing water, cavitation fluids, and how we can realize zero leakage. And now I would like to introduce you to the design of our ZK control valves. Now let's have a look at our severe service control valve, the ZK313. This is a valve suitable for the ANSI class 2500 or the nominal pressure PN 630. This valve can be actuated with different type of actuators. Here's an example of an electric multi-turn rotary actuator, but even pneumatic actuators are possible as an example. The valve trim design is made for differential pressures up to 5,300 psi or 370 bar differential pressure. The valve body itself is die forged, and here are different body materials available beginning from A105 up to F91. But now let's have a look at the trim parts of the valve, what is special and how we are able to handle these high differential pressures in a reliable way, and how we are able to keep zero leakage over a long operating time. This cut model shows very good the valve body. Here the die forged version and straight through in this case. Then we have got the valve bonnet here on the top, and we have got the gaskets between bonnet and body here, and the gasket under the seat bush here inside in the valve body. And now let's have a look at the trim design. The trim is consisting out of different parts. We have got on one hand the main valve plug here, and inside is installed a cone which is loaded by a package of disc springs. Here we have got the counterpart. This is a seat bush. And now we can see here two seats at these parts. Here we have got the main seat at the seat bush and the main seat of the main valve plug. And inside we have got the secondary seat, or we call it the tandem seat. And here is the secondary seat surface of the cone. And this design was founded at the end of the 70s to avoid erosion and cavitation damages during the closing and opening procedure of a valve. The main key and the main thing is always to avoid any erosion at the important seat surfaces to guarantee a zero tight shutoff. That means we fulfill ANSI class 6, or even we are better because it's a bubble tight shutoff. Now, how it works. We are going down with the main valve plug into the direction of the main seat. But before the main valve plug touches the seat, we are interrupting the flow with the secondary valve plug with a cone, which I want to show, or what I want to show now. Now let's have a close look at the tandem seat. The flow direction is through the radial stage nozzle from outside through all these stages into the center, and will leave on this way the valve. Now, if I'm going to drive down the stem, then I'm driving down the cone and the internal valve plug. I'm going down, and now at first I'm interrupting the flow here with the control edge of the cone. Then I'm going down with the cone on the secondary seat with what happens just now. Now I've got physically closed the valve, and I've got here still a safety distance of 2.5 millimeters, and this is enough to avoid any erosion damages. Now, after I've got interrupted the flow with a cone, then I can drive down the main valve plug on the main seat. And as you see, after compressing the package of the disc springs, the valve is now totally closed. If I'm going to open the valve, at first the main valve plug will leave the seat surface here, and after I have passed a safety distance of 2.5 millimeters, the internal cone of the tandem seat will follow and will give finally the flow free through the valve. This means that we have got two seats, and this has got the same function of a control valve plus an additional stop valve in one line. What are your benefits if you're using a GESTRA ZK control valve? On one hand, you have got a perfect tightness with this valve. You're combining a control valve and an isolation valve in one. And we can guarantee a perfect tightness by the tandem seat, that we have got two seats behind each other. On the other hand, you have got by zero leakage, no energy loss. You have got the advantage that if you're using the valve for spray water control, no risk of thermal shock damages in your steam coolers. Due to the multi-stage trim design, then we can handle high differential pressures in a safe way, independent if we have got flashing water, two-phase flow, or cavitation in the water. At the end of the day, all parts are changeable, including the seat. That means you have got an easy maintenance, the valve body stay in the line, and you can pull out all internal parts out of the valve, and you can replace it by new ones if it's necessary. As you have seen, the ZK valves are a real troubleshooter for your severe service application. So if you have got any valve issues with leaking valves, with erosion or cavitation problems, this is a solution. And I hope that you got some new ideas, some new imaginations, what we can do with our valve design. And now I would like to say thank you very much for your attention.